Dear friends, welcome to the next problem of gears, that is problem number 12. The data of the problem is like determine the minimum number of teeth and the arc of contact in terms of module to avoid interference in the following cases. Case A, gear ratio is unity. Case B, gear ratio is 3. Case 3, pinion gear with rack. The addendum of the teeth is 0.88 module and the power component is 0.94 times the normal thrust. Friends, let us note down the given information and prepare the diagram. Here it has been given that addendum is equal to 0.88 times module PC, that power component is 0.94 times NT, that is normal thrust. We have to find out minimum number of teeth of gear and pinion. Also we need to calculate arc of contact. Friends, as shown in figure, when gears are in action working condition, the power component PC acts along the line of common tangent to the pitch circles. It is T dash, and the normal thrust NT acts along the line of path of contact, or we can say line of action, or we can say this pressure line PP dash. So the angle between this normal thrust and power component is equal to pressure angle, that is phi. So from the figure we can write that power component PC is equal to cos phi into normal thrust NT, and in the data it is given that PC is equal to 0.94 NT. So we can write cos phi is equal to 0.94, and hence phi is equal to cos inverse of 0.94, and that gives 20 degree. Now considering case 1, when the gear ratio is unity, means G is equal to 1, that gives the number of teeth of gear to the number of teeth of pinion is equal to 1, hence capital T is equal to small t, and reciprocal of gear ratio will be also equal to 1. It is also given that addendum is equal to 0.88 times module. So we can say the addendum factor AW is equal to 0.88. Now we know that the minimum number of teeth to avoid interference of gear is given by this relation, and on substitution of the all values we found that capital T, that is number of teeth on gear required to avoid interference, is 10.84. So rounding off, the minimum number of teeth on gear capital T is equal to 11. Here again the gear ratio is 1, so both the gears have the same size, hence small t is equal to capital T is equal to 11. Now we know that arc of contact is equal to path of contact upon cos phi. Let us say it is relation 1, and the path of contact is given by path of approach plus path of recess. But in this case, both the gears are of same size, so the path of approach is equal to path of recess. So we can write path of contact is equal to 2 into path of recess. Now we know the equation for path of recess. So we can write path of contact is equal to 2 into this relation. Let us say this relation number 2. In this relation, small r is pitch circle radius of pinion given by m into number of teeth of pinion by 2. On substitution of value, we found r, that is 5.5 times module, and Ra is addendum radius of pinion, that is given by pitch circle radius plus addendum. On substitution of value, we find Ra is equal to 6.38 times module. Now, substituting these values in above relation 2, we found that path of contact is equal to 3.72 times module. Now, using relation 1, we can write arc of contact is equal to path of contact divided by cos phi. Substituting the values of path of contact and phi, we found that is arc of contact is equal to 3.96 times module. Now, let us consider second case where gear ratio is 3. Here G is equal to 3 means number of teeth of gear divided by number of teeth of pinion is 3, means capital T is equal to 3 times small t, and 1 upon G is equal to 1 upon 3, that is equal to 0.33. Now we know that the minimum number of teeth of gear to avoid interference is given by this relation, and substituting the values of AW, 1 upon G and phi, we found the number of teeth of gear is equal to 39.99. So the minimum number of teeth of gear capital T is equal to 14. So we can write the minimum number of teeth on pinion required is small t is equal to capital T by 3, and we found it is equal to 13.33. So the minimum number of teeth on the pinion, rounding off, we found small t is equal to 14. So accordingly, there will be change in number of teeth of gear. Hence, the minimum number of teeth on gear capital T is equal to 3 into small t, and that gives is equal to 42. Now we know that the arc of contact is equal to path of contact divided by cos phi, and path of contact is given by this relation. Let us say that relation number 3. Here capital R is nothing but the pitch circle radius of gear given by this relation m into number of teeth of gear by 2. Substituting the values, we found capital R is equal to 21 times module, and RA is equal to addendum circle radius of gear, that is pitch circle radius plus addendum. On substitution of value, we found RA is equal to 21.88 module, and the small r is pitch circle radius of pinion, that is given by this relation, and upon substitution of value, we found R is equal to 7 times module, and small ra is nothing but addendum circle radius of pinion, that is r plus addendum, and on substitution of values we found Ra is equal to 7.88 times module. Substituting these values in relation 3, we found path of contact on calculation is equal to 2.27 times module plus 1.94 times module is equal to 4.21 times module. Again, arc of contact is ratio of path of contact to cos phi. On substitution of values, we found arc of contact is equal to 4.48 times module. Now, let us consider case 3 when pinion gear with a rack. We know that for the rack and pinion, the minimum number of teeth on pinion to avoid interference is given by this relation, that is T is equal to 2 into AW upon sine square phi. Substituting this value, we found T is equal to 15.04. So the number of teeth required on the pinion to avoid interference is that T is equal to 16. Now, again, arc of contact is equal to path of contact divided by cos phi, and path of contact is equal to path of approach plus path of recess. In this case, the addendum of the rack and pinion is same, so the path of approach will be equal to path of recess. Hence, path of contact is equal to 2 into path of recess, and the path of recess equation is this. So we found on substitution that path of contact is given by this relation. Let us say it is number 4. Again here small r is the pitch circle radius of pinion given by mt by 2, and we found it is equal to 8 times module. And Ra again, it is addendum circle radius of pinion and is given by, that is 8.8 times module. Now substituting these values in relation 4, we found path of contact in this form, and on calculation it is equal to 3.98 times module. And arc of contact is equal to path of contact upon cos phi. So arc of contact is given by 4.24 times module. So we can conclude that for case 1, minimum number of teeth on gear to avoid interference is 11, and minimum number of teeth on the pinion to avoid interference is 11, and the arc of contact in terms of module is equal to 3.96 times module. For case 2, the minimum number of teeth on gear to avoid interference is 42, and minimum number of teeth on pinion to avoid interference is 14, and the arc of contact in terms of module is 4.48 times module. For case 3, the minimum number of teeth required on pinion to avoid interference is 16, and the arc of contact is 4.24 times module. Dear friends, thank you very much. Still, if you having any question, any problem, you are most welcome. You can write on comment. I will like to reply you. Thank you very much.